Okay, now see, in this question number 12, they say a balloon of volume. Now they have given you volume of balloon. So volume of balloon is 1000 cubic meter. Now this balloon is filled with mixture of hydrogen and helium gas. Now as the gas is being filled in the balloon, so whatever will be the volume of the balloon, it will be occupied by the gases. So you can say volume of gas filled in balloon will be equal to volume of balloon, because volume of balloon is 1000 and you are filling it with the gas, so gas will occupy that space within the balloon, so you can say volume of the gas is also 1000. Now this balloon is kept in air, so when the balloon is kept in air, it is going to displace equal volume of air. So volume of air displaced by the balloon, volume of air displaced by the balloon, as the size of the balloon is 1000 cubic meter, so when it is kept in air, it is going to displace air whose volume will be 1000. Hope this point is clear to you all. Volume of balloon was given, then the balloon was filled with gas, so volume of gas in the balloon will be 1000. This balloon is kept in air, so it is going to displace air, so the volume of air displaced will be 1000. Okay, now on the balloon there will be three forces acting. Now let's see what three forces will be acting on the balloon. Let us consider this as a balloon. So on the balloon we have one force which is called the weight of the balloon in the downward direction. The second force acting on the balloon will be weight of gases filled in the balloon. And the third force which will be acting on the balloon will be the upthrust. It is kept in air, so air will exert upthrust. So altogether you can see three forces are acting on the balloon. Two forces are in the downward direction and one is in the upward direction. Now which two forces are acting in the downward direction? One is the weight of balloon. Second one is weight of the gases filled in the balloon. And the one which is acting in the upward direction is the upthrust of the balloon. So let's calculate these three forces. First of all, we will get weight of balloon. As you can see, weight of the balloon is already given to you in the question. It's 40 kgf. Then we will get weight of gases. Now to get the weight, you must know the mass. If mass is not known to you, you must know the volume of the gas into density of the gas, then into gravity. Now volume of the gas is known to us, 1000. Density of the gas is given in the question. You can see the density of the gas filled is 0.32. 0.32. Now we are not using the value of gravity, so that means answer is going to be in gravitational unit. So when you multiply it, it is 320 kgf. So we have got these two forces, and see these two forces are acting in the downward direction. One is the weight of the balloon, the second one is the weight of the gases. Now there is one more force acting on the balloon, and that is upthrust. So let us calculate upthrust by air. Now to calculate the upthrust, we must know volume of the air displaced. See, whichever fluid is exerting upthrust, you must know volume of that fluid displaced. So here air is exerting upthrust. So we must know volume of the air displaced into density of air. Now here volume of the air is known to us as 1000. Density of air is also given to us as 1.32. So it's 1.32. We are not going to use the value for gravity, so our answer will be in gravitational unit. So we will be getting answer as 1320 kgf. Now this force is in the upward direction. So altogether we can see three forces are acting on the balloon. Two forces in the downward direction and one force in the upward direction. Now we need to calculate resultant of these forces. As you can see, upward force is much greater than these two downward forces. So the resultant force on the balloon we have upward force greater. So from the upward force you will subtract the two downward forces. One is 40 and the other one is 320. So when you will add these two and then subtract it, so 1320 minus 360, so that will give you 940 kgf. So this is the resultant force on the balloon. As you can see, upward force is more, so the resultant force on the balloon will be in the upward direction. So the resultant force is in the upward direction. So that means balloon is trying to move in the upward direction. Balloon is trying to move in the upward direction. Now this balloon is being held with the help of a rope. This balloon is being held with the help of a rope. The balloon is trying to move in the upward direction and it is tied to the rope. So the tension produced in the rope will be equal to the resultant upward force. So we can say tension in the rope is equal to the resultant upward force, that is 940 kgf. So this will be the tension in the rope. Hope this is clear to you now. So remember, in this case three forces were acting on the balloon. One is the weight of the balloon, downward direction, one is the weight of the gases in the balloon, and the third one is the upthrust. These two forces in the downward direction and upthrust in the upward direction. So first of all we have calculated all the three forces. Then we got the resultant because forces were not in the same direction, three forces. So the upward force was greater than the downward two forces. So from the greater one we have subtracted the two and we have got the resultant, and that resultant will be in the upward direction. So that will give you the tension in the rope. Hope this is clear to you now.